If you can go ahead and put your Penn State ID into the chat box, that would be awesome. And we are going to talk about lesson 9. So we're going to kind of expand upon our inferences, and we're going to talk about for 2 samples. So this is literally just going off of the basis of inferences for 1 sample, except we're basically going to have, either 2 proportions or 2 means here. So just as a review, our 5-step hypothesis testing procedure, basically what we do here is we're going to remember you have to check your assumptions and write hypotheses. And this is going to be different for every single, depending on if you have a proportion or a mean, and so what the different assumptions are going to be, and also, what like symbols you're going to use in your hypotheses. So, are you going to use a P, are you going to use mu? And then your second step is always going to be calculating that test statistic. So remember, we use Z for proportions, T for means. Then the last 3 steps are also very, always very similar. You calculate the p-value and then make a decision based upon the p-value, and lastly state a real-world conclusion. And so that's just a review of our 5-step hypothesis testing procedure. So we'll use that for every hypothesis test. Everything is just going to be specified that of each step, dependent on what we're talking about. So we're first going to talk about 2 independent proportions. So these are the conditions that have to be met for 2 independent proportions. So as you can see, these are very similar to our conditions that have to be met for 1 proportion. But basically, you're showing that we have the first sample size in the first proportion, and then our second sample size in the second proportion. So that's the main difference here. So both of those do have to be at least 10. So for each group, so for each proportion, so that's what we have, N1 times P1. That's going to be our first sample size times our first proportion. And, and then the second one, obviously. And then our standard error is literally the same format as if we were doing 1 proportion, except you have to do plus, and then the same, equation under that square root, except for your second proportion there. So same setup, if we only had the first half of that standard error equation, that would just be the standard error of a single proportion. But since we have 2 independent proportions here, what we have, you have to make sure you add that second standard error for our second proportion and sample size there. And okay, so then this is just basically a review of how we find confidence intervals, but it's specifically talking about confidence intervals for a difference between proportions. So here, remember, we are always going to have our point estimate. You can't really see that. Let's do another color. So we have our point estimate, and that's going to be this part here, and then plus or minus our multiplier, and then times our standard error. And then remember, our multiplier times our standard error is going to be our margin of error. And so this is just our confidence interval. Remember here, the main difference is we're just adding in the second proportion. And then same thing with here with our standard error. We're ensuring that we add in the second part of the standard error for our second proportion here. And our z-star, remember, since we're talking about proportions, we are going to use z-star for our multiplier for proportions. All right. All right, so now we're going to go ahead and through the 5-step hypothesis testing procedure for 2 independent proportions. So remember, for our assumptions, we do have to have that minimum of successes and failures that has to be at least 10. And it says there too for each group. So remember, you have to make sure you do N1 times P1 and also N2 times P2 to make sure that you're doing both groups there. Both of the groups have to have these assumptions met in order for you to go ahead forward. And then down here, we just, in that chart, we just have different examples of what your null and alternative hypotheses would be dependent on what your research question is asking, So if they're talking about them being different, you're going to be using that not equals to sign. Talking about them being greater than, you're going to have that, then you'll have the greater than sign, obviously, and so on and so forth. So it's just a good reference, if you want to double check to see if you're writing your hypotheses correctly. You can go ahead and look at this chart, and make sure that you are indeed writing them correctly. And also, just a side note, you can also write this as if P1 is equal to P2. for your null hypotheses, because if P1 is equal to P2, then P1 minus P2 is going to be 0. So this is another way to write it. You may see it in this format, you know, in some questions. So just remember these are going to be the same thing here. All right. All right, so then our second step for hypothesis testing for two independent proportions is going to be finding that test statistic. So the main idea here is we're still doing z, because we're talking about proportions. So we use, for proportions, we're going to make sure we use that z star. And then, see, the only difference here between a test statistic for one proportion and two is we have to make sure that we include this P2, P hat 2, in order for us to talk about two independent proportions. So that's the main difference here. You're still going to have your null of 0, and then your standard error of the null on your denominator. So that's just an equation to find it. And then our third step through our fifth step, very similar, going to determine your p-value, and then whatever your p-value is, you're going to decide between your null and alternative. So, you know, if your p-value is less than alpha, you're going to reject the null, and, you know, it's going to be in favor of our alternative. And then if our p-value is greater than, we're going to keep that assumption that the null is true, and we're going to fail to reject it. And then lastly, state a real world conclusion. You want to make sure that we're, you know, actually applying it to real life and using the data that we have to say, you know, this is something that this is like the conclusion we make about real life. So that's similar to when we would make those confidence interval conclusions, say like we are, you know, 95% confident that the mean like proportion of that kind of thing. Like we're actually putting it into, you know, words that show you what the real world conclusion is there. So yeah, these last three steps are basically always the same for hypothesis testing. The main difference is the third step, which you're, you know, depending on if you're going to have a z distribution or a t distribution to find your p-value. So remember, z distribution for proportions, t distribution for means. So that's the main difference for these last three steps. 4 and 5 are always going to be the same. All right, so now we're going to talk about two independent means. So this is just going to be, we're just talking about two independent proportions. So now we're going to move on to means. So we're talking about quantitative variables here. So once again, this is our equation to find our confidence interval for two independent means. Remember, we're going to use these symbols for x bar because these are going to be our sample mean 1 and sample mean 2. So this is going to be our point estimate, remember. And then our t value is going to be for means. We use t star for means. And remember, we use z star for proportions. So we have t star, and this is going to be our multiplier. And then lastly, we have our standard error here at the end. And the main difference between the standard error for two independent means and then for one mean is that you just have to make sure you add in this second part here to make sure you're taking into account the second standard deviation and sample size. So yeah, and then keep in mind this entire right side of the equation is going to be our margin of error. Once again, just to review that. All right. Okay, and then so once again, we're going to go through that 5-step hypothesis testing procedure. And so it's going to be for our two independent means. So remember, we do have to have these quantitative variables and our assumptions that have to be met for our two independent means is that the data has to be independent of each other, and then both populations have to be normally distributed, or if they're not normally distributed, you have to have a large enough sample size. So we usually use 30 in order for us to make that decision that it's going to be that's like a large enough sample size to say it's going to kind of cancel out the skewedness there. And then once again, you know, we have our mu1 and mu2 for our two different means, the two different groups. Once again, another way to write this, you could do mu1 minus mu2 equals 0, because that means they're going to be the same, so they do equal each other. So that's another way you can write it, and these are all the same here. And your alternative, you know, you have your not equal to for your two tail, and then you have greater than for your one, and then also less than, that's going to be your one tail, just dependent on what the direction is, you know. So if we're talking about greater than, we're going to have our p-value over here, And then left-tailed, we're going to have our p-value on the left side here, but they're still both one-tailed. And that's going to be in comparison to our two-tailed, where we would have the p-value is going to be both sides in terms of our z-score, or our t-score, excuse me, for means. Okay, so then our test statistic for two independent means, once again, remember it is a t-test statistic. And the main difference here, so when we were finding a test statistic for one mean, we would just use this right side of the, the left side of the equation. So all we're doing here to make sure that we're talking about for independent means is we're just going to add in this second part of the equation in order to account for, the two samples. So that's the main idea there. You just want to make sure that you use your standard deviation squared for your, and then, divide it by your second sample size, and then same with your second sample mean, to take both groups into account. Okay. And then lastly, remember these three steps are always very similar. So to determine that p-value, remember the main difference here is that we have our p-value that's going to be associated with our test statistic, which is going to be t for means. And then our last two steps always the same. You're going to determine, what you're going to say about the null and alternative hypotheses dependent on the p-value you found in step 3 with your test statistic. And lastly, state a real-world conclusion based upon what you found about, between the null and alternative hypotheses. All right, let's try some review questions. Obviously, go ahead and try these out. I'll read them out loud and then try to solve them. If you don't know, go ahead and type in the chat box that you want to go over it, and we can definitely do that. So here's our first one. So we want to test whether the treatment is significantly better than a placebo at relieving pain. The patients were randomly allocated to the two different groups, and the experiment was double-blind. Subscript 1 is the treatment group, and then subscript 2 is our placebo group here. So go ahead and find the relevant sample proportions for each group, and then the pooled proportion of them all together. So try to find these proportions, and then we will go over it together. All right, awesome job. So yeah, Lane, yeah, definitely got that one correct. So that was really good. So our remember we're talking about our p-hat 1 is going to be our treatment group. So this is our, we're talking about for our first group, and then placebo is going to be our subgroup 2. And so to find the relevant proportion for each group, and we're talking about, you know, if it's better than relieving the pain. So we're talking about this first row here. So what we want to do is for our P1, we're going to have that 42 divided by 81 in order to find that proportion. So we're going to get about 0.519. And then for P2, we're talking about, you know, for the placebo, so how much relief pain divided by our total. So we're going to have our 22 divided by 76, and that's going to give us about 0.289. And lastly, for our pooled proportion, we want to make sure that we're talking about our total here, because we're talking about everything that relieved pain divided by the total number that we had. So we're going to have our 64 divided by our 157, and that'll give us about 0.408. So those are our different proportions for each different group. So this is our first group, and then this is our second group, and this is going to be our pooled, obviously. All right, great job. All right, let's do a few more. All right, so using data from a study, we find significant difference in the proportion of fruit flies surviving after 13 days between those eating organic bananas and those eating conventional non-organic bananas. So if we were trying to test the proportion of fruit flies alive after eating the organic bananas, which is P subgroup 0, higher than the proportion of those alive after eating the conventional bananas, what would our null and alternative hypotheses be? So this is basically part of our first step of the hypothesis testing procedure. So go ahead and try to rate these, and then we will go over it. All right, great job, absolutely. So what we want to do here is we want to decide, because we're talking about the organic bananas being higher than our proportion, so that gives us a hint about our alternative hypothesis. But for in terms of our null, remember we're always going to have an equal sign. So that means our P subscript 0, so our organic bananas is going to be equal to you know, those alive after eating our conventional. So that's going to be our null hypothesis, and then our alternative is definitely going to be, since we're talking about the ones that are higher, we're going to see if our organic is going to be higher than, which is why we're going to have a greater than sign and then for the P subscript C. So great job, absolutely. So that's how we do our first step of our hypothesis testing procedure. So this is the same prompt here. The only difference is we give you the sample sizes, so the amount of fruit flies that are alive after eating the organic bananas, and then those alive after eating the conventional bananas. And then we do have, both groups have a sample size of 500 each. So go ahead and calculate that test statistic. I did give you the standard error there, so you don't have to worry about calculating that. And then we will go over this one. All right, let's go over this one quick. So basically, let's remember that we're talking about proportions here. So remember, when we're talking about proportions, we're going to make sure that we use our z-test statistic. So we want to make sure that that's the one that we're using, not t. So remember, when we're trying to find z, we're going to have our z equals, and then p hat 1, so our sample proportion for our first one. Yep, good job. And then minus our sample proportion for our second group. And then minus 0, our null, and then divided by our standard error of the null. So if we translate this here, we're basically going to get 345 divided by the 500 sample size, and then minus our p hat 2, which is going to be 320 divided by 500, and then minus 0, so that's still going to just stay at 0, and then divided by our standard error, which we're given up here, so 0.299. And then that's going to end up giving us about 1.67. So that is going to be our test statistic, which remember is going to be z star because we're talking about proportions. All right, awesome job. All right, so same idea here. So we have our p-value of 0.47. What's our conclusion going to be dependent on that we have this p-value? So try this one out. Basically, we're just trying to make that conclusion for a hypothesis test based upon our p-value. So see if you can think of the conclusion that we would make about this one. All right, awesome job. So remember, when our p-value is greater than our alpha, and we usually just assume our alpha level is going to be 0.05, then we're going to fail to reject. So here our p-value is 0.47, which is greater than 0.05, 5%. So that means we're going to fail to reject. So basically, we're still going to have that assumption that our null hypothesis is true for now, because we always start with that. So we're going to fail to reject. That's in favor of our null hypothesis. All right. All right, lastly, so find the standard error of the distribution of differences in sample means of x bar 1 minus x bar 2. Another, if you want it written like this, x bar 1 minus x bar 2. So sample size of 27 from a population 1. This is our first population with a mean of 6.4, standard deviation of 3.2, and then samples of size 36 from population of 2. This is our second population here, and then with a mean of 7.8, a standard deviation of 7.8 as well. So try to find the standard error for our difference in sample means, just to practice that out, and then we will go over it. All right, awesome job. So our standard error here is going to be based upon this equation. So we have our standard error of our first population squared, and then divided by our first population sample size, and then plus our standard deviation of our second population squared divided by our second sample size. So if we were to equate this, we're basically going to have our so standard deviation of 3.2. So we're going to have 3.2 and go ahead and square that, divided by our sample size of the first one, which is 27, and then plus our second standard deviation, which is 7.8 for our second group, squared, and then divided by 36, our second sample size. And then if we go ahead and solve this out, we're going to get about 1.44. So that is going to be our t-test statistic here, because we talk about t when we're talking about means. All right, great job, perfect. Okay, so let me know if you have any other questions. Obviously, you can go ahead onto the, I'm sorry, this is the wrong, this is not the right, like, you want to go ahead onto the YouTube channel to find that. But I'm sure you guys know where that is. So our next group review is going to be on Thursday for our next chapter. If you haven't already given me your Penn State email, please go ahead and type that into the chat box. If you have any other questions, yeah, absolutely. Let me know what your question is, and we will go over that. Okay. Okay, what do you want to know about that? Okay, so like you don't. Oh, you mean like the YouTube video that they show that so you're saying like on the YouTube video for that lesson. Oh, okay. I'm not sure. Yeah, maybe it's just, I don't know. Yeah, I would clarify that with your professor, because I'm not sure what they would want. I mean, if there's like a discrepancy, I would clarify that, because that's you know, obviously makes a difference there. So I would clarify that with them, because you know it might be different. You know, I don't want to say what they should do. You know, so I would clarify with them, I think. I'm not sure, like, I don't know which one they are assuming, you know, the one that they want it to be. So I would just clarify with them to see which one they think is right, you know, because I'm not sure if they have them both up there, it might be, you know, two different methods maybe. But yeah, I would definitely go clarify with them for sure. You're very welcome. Does anyone have any more questions? I haven't heard anything from any, to me specifically. I'm not sure. About what?